Hey guys, how's everything going? This is Jaser. So, I'm doing this series about React internals. I began the journey like 2 years ago. From the very beginning, I did a very raw video debugging how React uh, does the initial rendering, initial mount. But the thing is, I was not able to finish like backfilling even the first episodes on my blog because if you're diving into something, it's very hard for you to do a very good summarization about the whole picture without understanding each part of the system. So that's why, like 2 years later, actually 2 weeks ago, I managed to finish the writing about React internals overview. Yeah, and I think it's a time for me to remake the explanation video because, as I said, the original video was done by debugging and without me understanding the details. So it was kind of like I don't know what I'm doing, but I was trying to understand. But now I've already figured it out with over like if you take a look at the series, I've done about 30-ish, 34 episodes on this internals of React. So I feel more comfortable and more confident to explain it a little better this time. So yeah, hope you can hang on with me. If you're new here, if you prefer the raw debugging video, I think over 1 year long, how long is it? I think it's over 1 hour or something, 42 minutes. If you prefer that, you can watch that video, and here it will be much shorter. So before we start, I have a few tips on learning the React internals following my past 2 years experience. The first one is you need to read the React Dev as an awesome material over and over again. I think dive into every API and dive into all the pitfall explanation, try out all the demos. The React team is actually doing a very good job explaining their thoughts. It's very helpful. Another one is React Working Group. It's a place that the React teams and all those open source contributors discuss about the future, about the possible upcoming APIs, and it's also a very good place to learn what is going on. The second one is you need to follow the React team members. It's listed on the homepage. You can ask them and follow them on Twitter or any other social network. Like for Dan, many of them are trying to explain things and also joining the debates, and we will definitely learn from their chats. The other one is trust the code, not the posts. If you search about some topic, I think on the internet there will be a lot of posts, but to be honest, most of them are meaningless. That's from my experience. That generally people are just explaining some vague topics without even knowing what is going on under the hood. So it's kind of like everybody's discussing some vague thing, and nobody's really understanding it. And after reading the post, you still don't know what is going on, and somehow you have this impression that you understand it. But once you met the very tricky cases in your code, you still don't understand what is going on. Yeah, that's why I think you need to trust the code. Just to visit the React code base and spend time there. If you have any, you don't need to understand the whole code base. You just need to figure out the critical path. Oh yeah, as I said here, you only need to understand the small part of the system, and then glue them up and put them together, and then you understand the whole system. Anyway, so yeah, there's some tips, and here are some code I'm using in my episode for this debugging experience. Like we create an app component, and we use the state hook and add the debugger and the ESU effect debugger here. So we're going to render it. You can ask the demo here, and we need to set some extra breakpoints. The debugger obviously are gonna pause our code for us. but we need more. As an overview, we want to figure out how React actually manipulates the DOM, right? So here, we can just right-click the container here and set a breakpoint on the subtree modification. So by this, Chrome will pause when the DOM is being updated. And then we just reload and click run, and then the Chrome will pause, and we can see the call stack and figure out what is going on. So the first pause is actually the debug of here app. So that is where the app is run. So by here, we could have a rough image about how function components are run, right? So if we take a look at the call stack, the app is run, and here render with hooks. Possibly this is kind of like inversion of control. The render, it's not the app, the rendering is dedicated to the React runtime. And here mount indeterminate component, we don't know what is going on, but here's begin work, and here's perform unit work, work loop sync. So this is kind of like some work loop, like the event loop in Chrome. We can think like React runtime is continuously doing some work or trying to update some internal state. So that's called work. And here, here it's another one is post message. You can see that we have some API with the name schedule request, a schedule callback, and so you can see that this part is a scheduler that schedule work, which is not going to be run immediately because post here it's used post message, it's async. And here is update container, and then this is render React DOM root. This is corresponds to our user side code, React DOM create root and then render, right? So the entry point is here. So in summary, React DOM root render is the entry, is the user side code, and then schedule update on Fiber. Because I've already figured out how it works, so I explain without being a noob to the system. So this tells React where to render. You can think of it creating some tasks, creating some homework. And actually, when this homework will be done, will be scheduled by, eventually you will be scheduled by schedule callback. And this one is ensure root is scheduled means will ensure that the whole React tree, the React Fiber tree will be re-rendered. And the re-render itself is scheduled by schedule callback, and it calls to the exposed function from the React scheduler, and it's done by post message. The work loop is inside of React scheduler. By the scheduler, the name, you can know that it's about prioritizing. So if some work has high priority, it will be worked on sooner. If not, it will be later. So it just is basically a priority queue. And this perform concurrent work on root. You can think of it like a re-render everything. Because in React 18, we have introduced the concurrent mode. So by default, because we're here using create root, right? It's not the React DOM render thing. It's a new API, so we're using concurrent mode here. But I need to point out that even though it says concurrent mode inside of it, it will fall back to the sync mode with legacy mode under certain circumstances. Great. So you can see that this is how the call stack, how the app is rendered by the first breakpoint. The second one we will go to is the DOM manipulation. You can see that here we can clearly see that this manipulates the DOM parent, append child. You will do some insertion. Looking at the call stack, it's append child to container, insert something. It's all a DOM manipulation. And this one commit placement, it's just doing insertion, and it is inside of commit reconciliation effects. Reconciliation means that basically means the reconciliation of children. So for children, for a node, it has children. For the children, there'll be, I think, three states, right? If the children has the same type, then you will be try to be updated, so it will be recursively worked on. Other than that, it will be insertion or deletion, right? And this reconciliation here, I think it basically means the placement with the insertion. Mutation effects. Mutation, it basically means the mutation on the host DOM. And it's also done recursively. Commit, mutation, commit root, commit root. And this all are done in the commit phase. We will cover it soon. And then this is finished, render, concurrent render. This is perform concurrent work on root. So from this call stack, we see that after we create the homework and the scheduler schedules schedule the work and get it done, and then we will go to the commit phase. Everything will be committed, and inside of this committing, the DOM will be updated. So here, the perform concurrent work on root, not only it just updates the fiber tree internally, it will also calculate the minimum updates for the host DOM. And in the commit phase, we are able to do that, to just execute those minimum actions. Great. And the third pass, we will go to the effect. Like the use effect is one of the most confusing hooks, I think, inside of React. But as we were familiar, use effect runs some like a function after the DOM is done. Obviously, this function is not called asynchronously. We can see here it's also done by post message, so it's async, and also it's scheduled by scheduler here. And interesting is like, okay, here request callback schedule. Yeah, this will be scheduling, and then it will work, and it will work on this effect updates, and we see the flush passive effect. So internally, those use effect hooks are called passive effect. And here commit passive mount of fiber, this mount. Yeah, and then the callback is run. And then set count is triggered, and then this component will re-render, right? State if changes, the component will re-render. Actually, the re-render it starts from the root. So the set states is actually doing two things. The first one, it will create some homework on the specific fiber, like on this the internal node for this component. But at the end, it will call the ensure root is scheduled. Like say, hey, okay, I've set some work here, but please re-render the whole React fiber tree when you find it appropriate. It talks to the React runtime. Yeah, remember this function. It also is scheduled inside of commit phase. Great, and re-render happens. The debugger will pause. We will pause at this debugger again. If we take a look at the call stack, actually it basically are the same, right? Except the third one, update function component is a little bit different from what we see at the beginning. It's mount indeterminate component. We'll cover this soon, possibly in the next episode. You just need to remember this one is for initial mount because there's no previous version yet, so it's mount indeterminate component. And in the last pause, we've already have the first version because this update is scheduled inside of use effect. It's async, and then we have the previous version. So we are actually comparing two versions, right? This is new one. We have the previous one, so it's called update function component. Great. So basically, if we only need these 4 or 5 breakpoints to generally understand the whole system. Here's the summary. Obviously, it's very hard for me to explain this at the debugging video. So here, I've separated into 4 phases for the React internals. Somebody doing like in 3 or with maybe one more, but anyway, this is just my understanding. The first one is trigger phase. No matter it's initial render by this React DOM root render or you trigger the update by the state hook, they will do 2 things. The first one, they will schedule work, like they can mark the part of the application, say, okay, we need to update this part or that part. That's done by schedule update on Fiber. For Fiber, did I mention Fiber here? No, Fiber is explained in the next episode, but just to remember, Fiber is the internal representation of the whole React application. They're not one mapping for the host DOM, but for context or forward ref or anything else, there are nodes that don't have a backing DOM node. Anyway, this one is marked Fiber tree, and then it will call ensure root is scheduled. It will say, okay, please re-render when you find it appropriate. This is trigger phase. It's just to trigger the scheduler. I don't think it's trigger the scheduler, but making preparations. Okay, schedule is scheduler. Schedule will, because we call this function with some task, scheduler will prioritize the task based on their priorities and then execute those tasks with the workload. I put a dotted circle here, meaning that it's a separate part of the system. And then we're going to render phase. As I said, perform concurrent work on root. Every re-render will start from the root. Obviously, you might think it's kind of not performant, but React try to ignore the subtree if it doesn't found any updates. We'll cover this soon. Anyway, inside of this work from root, there were 2 kinds of rendering mechanism. For one is real concurrent mode. The other one is sync mode, legacy mode. As I said, even if we call perform concurrent work on root, if the event is click, it means that it has high priority. So the work will actually use sync mode, even though it's under concurrent mode. So this kind of 2 mechanism inside of it. And in render, it will try to update the internal representation of the web of the app, which is the Fiber tree. It will, if there is a previous version, they will compare it and try to reuse the Fiber and use minimum actions, right? Minimum commands, I would say, minimum commands to sync to the host DOM. And during the render, during the render phase, it also marks the Fiber with the commands. The first one, you will update the Fiber and then calculate the commands, and then the command updates the commands. The commands will be used in the commit phase. The commit phase is synchronous. There is no concurrent thing. Commit, as the name implies, it will commit the changes to the host DOM, and then inside of it, here you just commit the mutation effects, which is update the DOM. Like if after the calculation, if it's deletion, we will delete the nodes. If it is insertion, we will commit the placement. If it is update, we will update the properties of DOM nodes. And after it, it will also kicks off the effects. We have a pretty awesome effects like layout effects, which allows you to access the DOM synchronously, and also passive effects, which is created by the use effect, and also now we have the insertion effect, right? All kinds of effects. They will be executed in a different timing comparing to each other. But that's all done after the DOM is updated. So this is the overview for the system. Remember trigger phase, and then the re-render is being scheduled, and inside of the re-render, it will walk around the tree structure and do those comparison, do those insertion to create a new fiber tree, the internal representation of the web app. And then also it also calculates the necessary commands to sync to the host DOM. And those commands will be executed in the commit phase, the last phase, and reflect to the host DOM to make it be up to date. And also it will run the necessary effects after that. So this is the overview. For each phase, I've put some links for you to understand it better. For render, I've explained how React traverse fiber tree internally, and also there are also some. Here is the coding challenge. It's pretty interesting. And for commit phase, we'll explain use layout effects, use transition. So from this overview, you also see what I explained in the final minimum critical path. You just need to figure out the small part of the topics, the small topic, and then put them together like a network of the knowledge, and then you understand the whole thing. That's all for this 20 minutes. Hope it helps. See you next time.